I'm Dr. Mohammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about problems and solutions on a socket options on elementary UDP sockets. Here is socket options elementary UDP sockets. What are the problems now we are facing in a network programming or network other management? So what are the other solutions for that one now? So today we'll discuss about this problem solving some solutions. Here is the problem is first the problem is in a network other programming configuring socket options. So first issue is a configuring socket option. Why would you have to configure the socket options? That means with help of these the socket options now we can send the data or we can receive the data. That means socket reuse address can be done with help of these socket other creations. These are the socket options can be considered as both the client side and server side. Now we can consider the socket. Here is the client side. Client side we can create the socket, and similarly at server side also now we can create the sockets. With help of these the sockets only now we can sending the data or we can receiving the data. The communication, the effective communications can be established with help of the sockets. That means here is what are the issue. Before creating the socket now, we have to, the problem is the socket the configuration. Socket the configuration is the problem. Configuration. When you configure the socket, then only we can send the data, then only we can send the information. You might want to allow the multiple sockets to bind the same port. Here the multiple sockets can be bind the same port, especially during the developers while developing and when restarting the server. So this is the issue. Solution for that one, the optional value. Here is the enter, the optional value is a 1. Host the optional value will be considering it as a 1. 1 is a host optional value. After considering the optional value, set the socket option. Here is socket option. How we are going to setting with help of the socket option? We are utilizing the function. The arguments are socket file descriptors. We are utilizing for setting the socket option, and socket layer. We are utilizing the socket layers, and also socket reuse address also we are using, and OPT value, optional value address also we have to utilize, and size of the optional value. So by using these the function now, these are the function so which allowing the sockets to bind to the port even if the previous connections on the port in a time wait state. Here it is a solution for that one. Problem is setting in the receive buffer size. Here buffer size, receiver buffer size also we have to set. That means so receive buffer. The issue, what is the issue will arise here? The default buffer size may be too small. While creating the buffer at the server side or client side, here default the buffer size is very small for the high throughput of the applications. This is the problem. For that one now we have to setting the receiver buffer size or increasing the receiver buffer size. How we are going to receiving the increase the receiver buffer size means here the declaration receiver into receiver buffer size is the size is 1024 into 1024. That is a 1 megabytes set socket option. So that is we are setting as a socket file descriptor, socket option, set socket option, the function we are utilizing, set socket option, socket file descriptor, socket layers, socket receiver buffer size, receiver buffer size, size of the receiver buffer size is increasing. So adjusting the buffer size, whether it is increasing or optimizing, by optimizing the buffer size, the performance can be increased. Optimizing the performance of the buffer based on the whatever the applications now we are utilizing. So this by using this is the function now we can set the buffer size. We can increase the buffer size. Next, the problem is receiving the data in a correct order. So it is also one problem. So while establishing the communication, now receiving data in a correct order or receiving data in a sequential order is a problem. So for that is a UDP is a unreliable. For that now what we are doing, UDP does not guarantee the packet order delivery. User datagram protocol, if you are transferring the data, so which is not give the guarantee for the correct order of the delivery. For example, now UDP we are using WhatsApp or the chat GPT, so which is not give the correct order of the delivery. So the sequencing can be the change, which might lead to the data being received out of the order. Here, out of the order, data receiving should be the out of the order. The solution for that one is implementing the sequence number in a payload of your UDP packets. That means on the receiving end, reorder packets based on the sequence number before the processing. Here is now, so this is the solution. That means first we have to implement the sequencing number. By implementing the sequencing number now in a payload of the UDP packet, we can sending the correct the data in order data in the sequencing order. Now we can send on the receiving end, reordering the packets based on the sequence number only. We have to send sequence number only before processing. Problem is handling the large datagrams. So if you want to handle the large datagrams now, so it is the problem. The issue is UDP datagrams are larger than the maximum transmission units MTU. The datagram size is very large. Now it is a problem for handling the large the datagrams over the network. So it is a big issue. So UDP datagrams are very large than the maximum transmission units. So maybe the fragmented at the IP layer. The fragmentations will be arise and leading to potential other issues if the fragments are lost. Fragments are lost. The solution is which ensures your datagrams are the very smaller than the typical MTU. Usually around the 1500 bytes. Around 1500 bytes. So use IP MTU discover to a set. Don't fragment flag and handle large data with the application level the fragmentation if it is necessary. So with this by using the IP MTU discovery, by setting the don't fragmentation flags and handling large data with applications, any other applications level fragmentation if it is necessary. And datagrams are, you have to ensure the datagrams are very smaller than the MTU. So typically around the 1500 bytes. With this with these things now we can handle the larger datagrams in a network. Next problem is the binding a specific interfaces. Here is issue is if a server has multiple network interfaces, you may want to bind the UDP sockets to a specific interfaces. UDP now, which is you want to binding the UDP sockets to the specific interface. For that one here, the code is structure socket address in address address add or dots sin family add dot, it is a SIN family equals to address family INET, which is assigned to the SIN family. AF the family, now we are going to assigning to SIN. Here is, it is a binding to a specific interface with help of this code. Now addr SIN address family dot S underscore address. Now INET address family, that is a AF address of the family. The IP address for that one is 192.1. So it is a specific interface. 192.168.1 is a specific the interface, specific the IP address. That is IP address dot SIN, the port number we are giving, binding the socket file descriptors and socket address and size of the buffer. So these are the code with help of this code now which bind the sockets to a specific IP address. So this is a specific IP address that can be bind to the particular socket to specific IP address, which is ensuring it only the listening on that the interfaces. Here is the problem is non-blocking socket operations. Non-blocking socket operations. The issue is blocking calls can causes the applications to hang if no data is available or the network is very slow. That means the solution is function control. So here it is this one, whatever the files we are going to the transmitting, with help of this function now we can control the files. So FCNTL, it is a file controller. File controller, in this file many functions can be controlled. File which is controlling the file descriptors, file set FL O underscore non-blocking files. There is a related system calls IOCTL. So that is a input output control. So IOCTL is a one system call. The difference between these two is the FCNT file control. This file control is the which modifying the file descriptors, whereas IOCTL which is control the behavior of the input output device behind the file descriptors. Handling the broadcast messages. The issues are sending broadcast the messages which is required, enabling the socket options for broadcasting. This is the issue. The solution for that now, broadcast will be assigned to the one and set the socket the option, that is socket FD SOL socket SO socket broadcast. So at broadcast the size of the broadcast. These allow the socket to send the broadcast messages. That means here the problem is packet loss in a high traffic scenarios. Packet losses, if the traffic is a very high traffic, now some of the packets will be losses. The issue is UDP doesn't have the built-in transmissions, so packets can be lost under the high traffics. The solution is implementing the application level acknowledgement or retransmission. Consider the switching to TCP if the reliable communication is very crucial. So this is the solution for that one. Next, the problem is sending the data to a unreachable host. Generally here, when it is unreachable host means now if any host problems are arise, any network issues are arise, so the sending is very difficult now, we can't send the data. The issue is here, if you send the data to an unreachable host, that is by utilizing the send to, might return an error. This is the problem. And the ICMP protocol, unreachable messages might not be the immediately proceeded. That is, the solution for that one is handling the error returns by send to and implementing the retry logics. So if is there any errors, that will be handled and implement the retry the logics. Use the get socket with SO error to retrieving the error status after a failed send operations. Next problem is receiving from the multiple clients. If you want to receive the data from multiple clients, some problems will be arise. Here the a server using the UDP needs to handle the request from the multiple clients. So, but UDP is a connectionless. So, this is a problem. For that now, what we are doing now, we are using the receive from method or receive from the function to getting the client address along with the data. By using this as the function now, we can receive. Respond the client using the send to, which is specifying the client address. With help of this send to and receive from here, with help of these two functions now, we can receive the data from multiple other clients. That means the server can receive the data from multiple other clients. This is the implementation for receiving the data from multiple other multiple host or multiple other clients. The code is structure socket address in the client address socket length. So that is a address length, the size of the client. Here the character, the buffer, the port number is a 1024. Int n is equals to receive from socket FD buffer size 0 struct socket address and a client address the length client address and the length process the data. So with help of this send to now we can send the data. With help of the receive from now we are receiving the data from multiple other clients. From the multiple clients now we can send the data with help of the send to functions. So these are the problems and solutions should help the address some common issues encountered when working with the socket options and elementary UDP sockets that can be resolved. Generally, real-time streaming packet will be losses in a real-time streaming. So in a real-time the application, so that is a videos or audios, the packet losses can lead to degrade the quality such as a glitches or dropouts. The quality will be the dropouts. So in a packet loss in a real time that is streaming. The solution is to implement the FEC forward error corrections. Implement the FEC forward error connections. Now which is include the redundancy. So in a transmitted data to recover lost packet without needing the other transmissions. This is a solution, that is a forward error correction. Is a by implementing this one here that can be packet loss can be resolved using the small packet sizes. So it is another solution. Reducing the packet size can decrease the chance of loss instead of the bulk packets. So small packets are very less losses can which leads to very loss drops in our congestions. Monitor and adapting of the transmissions streaming can be adapted. If you adapt the streaming here now we can reduce the losses, adjust the quality based on the network the connections, and also the problems out of order packet delivery. So in a real-time communications are receiving the packets out of orders can disrupt the follow up the data which leading the incorrect payback or other processings. Sequence for that one you are using the sequence number we are using. By sequence number now out of delivery packet can be resolved, and buffering by buffering also out of packet delivery can be resolved. Security in a real time. So issues some securities like spoofing, flooding, man in the middle attacks, especially in the real time applications. So various attacks will be happen. UDP is susceptible to all these things. So this is the problem. The solution for this now we are utilizing the encryption as a technology. By using the encryption technology now you by in this encryption technology we are using DTLS protocol, datagram transport layer security protocol, to encrypt the UDP traffics and validate the input and rate limiting and monitoring. So with help of these the techniques now we can provide the more the security for the whatever the data communicating in a UDP in a real-time applications. Here for this textbooks, these are all the textbooks, and it is a web reference textbook is a Unix network, the programming volume on socket network API by the Richard Steven, and this is the textbook, and this one is a github.com is a reference for this topic socket options and elementary UDP sockets. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.